Okay, so in this video, I'm going to go through a couple of ways that we can handle error messages in problems. So previously, when I changed one of the inputs, we got imaginary parts of the roots. So basically, there was no point where the parabola crossed the x-axis, so there's no roots to that equation. Now, we want to handle that particular case, and the case where we'll only have one root. So we'll look into a few of those quickly. So there's a function that I want to introduce, and it's called error. So I'm going to type help error, and we'll just have a quick read through this. So error displays an error message and aborts a function. Okay, so this is where we can start introducing some error handling. So in the case that this is going to have imaginary roots, I want to stop doing any calculations and I just want to stop. So to do that, we're going to put a if statement in there and display an error message. So before I do anything, I'm just going to write a little comment. So sorry, I don't write as many comments as I probably should. Handle case where no roots. Alright, so to do this, so we've got to work out where we're getting our imaginary numbers from. Now, those that have never touched imaginary numbers before, typically you can't take the square root of a negative number. If you take the square root of a negative number, you get imaginary numbers. If you go into electrical engineering, you'll use this quite frequently. Other disciplines, not so much so. But the point where we get imaginary numbers introduced is this square root inside of our roots equation. Alright, so inside, the only time that this value inside of the square root is going to be negative is when 4 multiplied by a multiplied by c is larger than b squared. Alright, so sorry, so we're going to write an if statement. So if 4 multiplied by a multiplied by c is larger than b squared, this is the case where we're going to have imaginary roots. What do I want to do? I want to display an error message. So error, using some of this one of these layouts. I'll probably use this one here. So error, and we'll just give it an error message, and we don't really care. So error, the error message is no roots to this parabola. Alright, something simple like that. Put an end there. So now what error does is that it aborts a function and displays an error message when this is the case. So let's save this and let's test it. Testing is very important. So parabola of 1, 2, and negative 5 still works. So that's one of the cases that we had before. Let's do it when we've got positive 5. So just positive 5. We get an error message and a little ding letting us know that. So error using parabola, no roots to this parabola. So fantastic. Our error message is working. Now there's another case that might be a potential issue for us, and that's the case where there's only one root. Okay, so in the case that b squared is equal to 4ac, then we get a 0 for the square root of that. So the square root of 0 is still 0. And so plus or minus 0 doesn't really matter, and we'd get the same root. Now, to sort of signify that, let's make that a special case as well. So I'll do it down here. So calculate second root if necessary. If b squared is equal to 4 multiplied by a multiplied by c, r2 is equal to not a number, so not a number is a special case, and else we do this one and type end. So doing that, we got rid of all our error messages. So let me just think. I'll need a case where, okay, so if a is equal, like if all three values are the same, that should work, shouldn't it? Yep, maybe. So let's type parabola of 1, 1, 1. So, oh no, wait, we'll put the 4 in there as well. So if b is equal to, I know one way, this is just x squared. X squared only has one root. So 1, 0, 0. So let's just check this one out. So a equals 1, so it's definitely a parabola. So 1 times 0 times 4 equals 0, and 0 times 0 equals 0, so we don't have a second root. So let's have a look at this one, and we need to give it both of our outputs this time, so R1 and R2. And I doubled that one, so that. R1 is equal to 0, and R2 equals not a number. So that's fantastic. That worked. And we're starting to handle quite a lot of cases. So these are a couple of really useful tools, and I'm going to introduce one more in this screencast, and that's using a function called nagin. So nagin is the number of arguments in, and as you can see, the last time that I called this function, I nearly did this. I nearly only gave it one input. Okay, so error using parabola, not enough input arguments. So we can handle the specific case where we might not give it enough inputs. Alright, so let's just get rid of this guy because we don't really need him. Handle fewer inputs. Okay, and we're going to assume higher orders filled, lower orders 0. Alright, so that's just saying that if we only give it one input, we're going to assume that A is that value, and then B and C we're going to equal 0. So if nagin, so nagin is a variable in MATLAB that is worked out for you, and it's basically in a function. It counts how many arguments are given in as an input, and so we can do a comparison with a value and handle that specific case. So if we only give one input argument, we're going to assume that that value is equal to A, and then B is equal to 0, C is equal to 0. Else if nagin is equal to 2, C is equal to 0, so we're going to assume that both A and B are the ones that are filled. And else if nagin is greater than 3, this is when we have an issue. So if we've got more than 3 inputs, then it's not really a parabola anymore. So we'll put another error message here. So error, too many input arguments. Alright, and that one. So I've saved that. Let's have a run of our previous example. So just giving it one input argument, R1 equals 0 and R2 equals NaN. So that's the same as when we went 1, 0, 0. We can give it 2. So that now works. That's fantastic. We can give it 3. So no roots to this parabola. 1, 2, minus 3. Cool, that works. And finally, if we try 4, too many input arguments. Alright, so introduced a couple of ideas. We introduced Nargin, and we introduced this error function, and we introduced handling a couple of exceptions, so understanding what's going on inside of our function. Alright, so I'll stop the screencast here.